Okay, so last time we've been working in integration by parts, and we know that the integral of u dv is equal to uv minus the integral of v du, and we did several problems. Most of the problems that we did all had a power of x in them, like x2 the third or something like that. And we found out that if you're doing just one little problem with x, we only have one integration by parts problem. But if you end up having x squared or x cubed, you have 2 to 3 integration by parts problems. And so then I came up with a little formula of how to do this. So how to compute how the formula works when the integrand contains x to the n and n is a positive integer, you can make this chart. All right, so when you make this little chart here, all right, so here's your chart. You start with the derivatives on the left-hand side, the integrals on the left, and the last problem we were working on was this. And I just didn't get to simplify it. So we had the integral of x cubed e to the 2x dx turned out to be 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 3/4 e to the 2x. Something is wrong. I got 3x squared, 6x over 8. That's right. Oh, that's right. Okay, so 6 over 8 is 3/4. Yeah, it's still right. X e to the 2x minus, and then 3 over 8. E to the 2x plus the constant. Okay, so that's how we do those problems. And these are the easier problems. You can use them, you can use the formula for any power of x to the n. So now the difficult integrals with that are things like the integral of the tangent of x and the integral of the log of x. So I'm going to do the integral of the log of x. As I told you, there were some integrals where the traditional rule does not work. Okay, so these are the, I would say this is the 5% of integration by parts problems that don't have something like x to the n. Okay, so this 5%, so most integration parts problems have some x to the n in them, but this 5% don't. And they are the most difficult, and they are things like the integral of the log of x, okay? So this is a tricky kind of problem. It's a little bit different than the other ones. Here, I am going to let u be log x. And dv is now the only thing that's left. So u is the log of x. So dv is just dx. It's the only thing left. And so du is 1 over x dx. That's the derivative of the log. And then v is simply just x. Okay, so this problem doesn't fit the norm. For the first time, we actually made u something kind of difficult. All right, so therefore, when we go to solve the problem, we get the integral of the log of x is equal to, so let's ourselves, the integral of u dv is equal to u times v minus the integral of v du. So let's do that. So this is u, and this is dv. All right, so it's going to equal u, which is the natural log of x, times v, which is x, minus the integral of v, which is x, times du, which is 1 over x dx. Okay, so this is u, and this is v, and this is v, and this whole thing is du. Okay. So now I get, this is x times the natural log of x. All right. And then this is minus the integral of, the x's cancel, so I just get the integral of dx, but that thing is just x. So now I can write my answer. So this is going to be x times the natural log of x. I'm going to subtract off x, and then I'm going to add a constant. So now we know how to integrate log. We didn't know how to integrate log before. Okay, so this is the first time we're able to actually integrate the log function. Okay, we've actually been able to integrate integrals that had log in them, but we were never able to integrate the log function. So there is how to integrate the log function. Okay, the one I want to do is the tan inverse. If I can find it, here it is. Oh, I'm going to have to rewrite it. It's not going to give it to me. All right. So I need the integral of the tangent inverse of x dx. Okay, so this is the one we want to work on. All right, so we want to let u, this is another one that's going to be different. Like I said, the 5% of integrals that are different. Let u, again, now we're going to choose it to be the tan inverse of x, and dv is going to be dx. So u takes up this whole piece. And dv gets what's left. Okay, so now derivative of u. What's the derivative of the tan inverse, guys? The derivative of tan inverse.
It's 1 over, or if I think of integrals for
1 over?
1 plus x squared.
Good. All right, and then we get to integrate this. V is equal to just x. Okay, so let's do our integral. Uh-oh, I don't want that one. I want this one. Okay, so this is the one. Okay, so uv, so u is tan inverse, and v is x, minus the integral of v, which is x, times du, which is 1 over 1 plus x squared dx. Okay, we're getting somewhere. All right, so this is now x times the tan inverse of x minus the integral of x over 1 plus x squared dx. So now I have to work on this little integral by itself. So let's work on that integral. So the integral of x over 1 plus x squared dx. For this one, I'm going to let u equal 1 plus x squared. Du is equal to 2x dx. So now I'm just doing a regular u substitution. Okay, so this is a regular u substitution. I'm not doing the u dv. I'm just doing a regular u substitution. Okay, and so that means x dx is 1/2 du. Okay. All righty. So this now gives me, this is the integral. X dx is 1/2 du. And 1 plus x squared is u. So this integral is 1/2 the integral of du over u. And we know that answer. That's 1/2 the natural log of the absolute value of u plus a constant. So this turns out to be 1/2 the natural log of the absolute value of 1 plus x squared, which we automatically know is positive. Okay, plus a constant. All right, so now we're done. So we can put that in for our final answer. Notice I just had to do a little u sub after I finished my problem. Uh-oh. Okay. So this is now going to equal x times the tan inverse of x minus 1/2 the natural log. I don't need the absolute values because that thing is always positive, but I am going to throw in my plus c. So there is my answer. Uh-oh, wrong shape. Okay. All right, so there's one last topic on integration by parts, and this one is a little tough. It's when you have a repeated integration by parts. I don't mean like this problem where you have to keep doing it 2 and 3 times. When I say repeated integration by parts, this is more like a wraparound or a cat chasing its tail. So let's call it that, a cat chasing its tail. Okay, so this one is very much like the cat chasing its tail. Okay, so it always happens when you have things whose derivatives continually grow, just go. Like e to the x is e to the x is e to the x is e to the x. Cosine goes cosine sine, cosine minus sine minus cosine sine. It keeps going like that. So we have these integrals that kind of wrap around and chase their tail. So we're going to do 2 of these. So let's do the first one. All right, so this is the first one we're going to do. So we're going to start off with e to the x times the cosine of x. And I'm going, so it really doesn't matter which one you do here, but you need to be consistent. So I'm going to let u be e to the x. And I'm going to let dv be the cosine of x dx. Okay, so at this juncture, I just want to ask, is everybody okay with me choosing u and dv and then
I
finding,
just like the most simple option.
what's that, Max? Max, what'd you say? Okay. So u is e to the x and dv is cosine x dx. So I have my u,
Professor Watt,
yes,
just to clarify, U is always the first term, except if it's not.
no, u is what you want it to be. So in this problem, I couldn't make u dx because u can't be a derivative. So I made u the function and dx the derivative. Actually, if you like, I can do this problem where u is cosine and e to the x is dv. I can do this problem that way. U does not always have to be the first thing.
Okay.
Okay. All right. So now du is e to the x dx, and v is the integral of the cosine, which is the positive sign. Okay, any questions so far? Okay, so I'm going to take my integral and I'm going to write it. So I'm going to get u, which is e to the x, times v, which is the sine of x. And then I'm going to subtract off the integral of v, which is the sine of x, du, which is e to the x dx. And so now I get that the integral of e to the x cosine of x is equal to e to the x sine x. But now I get an integral that looks like the one I just kind of started with. So this integral is just as difficult. This integral, all right, is similar to the first integral. So this is similar to my original integral. That's why I call it cat chasing its tail, because I'm trying to find this one, e to the x cosine of x, but I also now need to find e to the x sine of x dx. So let's find that one. Okay, so now we have a new problem. New problem is we have to find the integral of e to the x, the sine of x dx. So I'm going to let u equal e to the x, and I'm going to let dv equal to the sine of x dx. Okay, so this is a new problem because I have to figure out this thing. I have to figure out this. So that makes for a new problem. Okay. So if I let u be e to the x in the first problem, I'm going to let u be e to the x in the second problem. And dv is the sine of x. So now I get du is e to the x dx. And v is the integral of sine, which is question. Okay, I'm good. I was worried about my signs, but I'm good.
Dr. Love,
Yes, Victor.
sorry. When it comes to the integration by parts, is how do you know when you I know like every problem is different, but is there a particular thing you have to do when approaching like a stopping point? I guess I think it's one of the difficulties I have with.
When you say a stopping point, what do you mean?
I mean, when you're approaching maybe like the end towards, such as like with what we're doing, like repeated integration, if like there's like an end point to which like once you finish a, I guess when you're, I guess making the finishing calculations to like one particular problem, and then you just writing out the entire problem as it should be. I guess,
Okay. All right. So that's going to come up in this one. So let me show you where that's going to come up. Okay.
Okay.
All right. So that's a good question. So notice this one we're trying to solve. So we're trying to solve for this. Okay. We need that because we can't finish the original problem until we get that. Okay. So we need that original. We need that. So until we get yeah, we need this to go into that problem. All right, so now we have the integral of e to the x sine x dx is equal to uv, which is e to the x times minus the cosine of x, minus the integral of v, which is negative cosine of x dx. I'm sorry, v does not have a dx on it. That was crazy of me. V du, which is e to the x dx. So now when I do this, I get the integral of, I want a black integral. The integral of e to the x sine of x dx is going to be minus e to the x cosine of x. See if they minus makes plus the integral of e to the x cosine x dx. Okay, so this is why I called it cat chasing its tail. So everybody see what I'm talking about? All right. So I started off with e to the x cosine x dx. And when I was solving the problem, it was in terms of e to the x sine x dx. But then when I did the integral e to the x sine of x dx, it just gave me another e to the x cosine x dx. So let's see what happens then. So now we have the integral of e to the x cosine x dx. And that is equal to e to the x sine x minus the integral of e to the x sine x, but the integral of e to the x sine x, I'm going to put in what I got, which is minus e to the x cosine x plus the integral of e to the x. Plus, oh my gosh, I got that integral again. Okay. So now I have the integral of e to the x cosine x. Remember, this is what I'm trying to solve for. Is equal to e to the x sine x plus e to the x cosine of x. And now I'm going to subtract off that integral. So basically, I have the integral on one side and negative the integral on the other side. So I can take this one right here. I can take this one and add it to the other one on the other side. And that's what I'm going to do. So when I do that, I get two of them. So now I have two of them. And that is equal to e to the x sine x plus e to the x cosine x. But I don't want two of them. I only want one of them. So I'm going to divide by 2. So that means this is going to equal e to the x sine x plus e to the x cosine x divided by 2. And I'm finally done, plus c. So that is the cat chasing its tail problem. Okay, any questions about that?
I have one.
Yes.
What you changed this? Why'd you change the sign?
Because I distributed the negative.
Got you.
Yep, that is so important. That's why I paused a minute ago when I was doing the integral, because I said, uh-oh, I don't think my negatives won't work out right. And then I would have to explain why I made a mistake, which I didn't want to have to do. So they worked out fine. Okay, so I'm going to give you 2 to do right now. Before I'm not going to even do this other one right now. I'm just going to give you 2 to do for practice. So the first one's going to be okay. So that's the first one we're going to work on. I forgot to restart the recording. So let's go back and talk about this one. So we did this one, x sine of 2x. So we needed to incorporate the v being minus 1/2 the cosine of 2x. And then we put uv minus the integral of v du, which left us the integral of now cosine 2x, which was 1/2 the sine of 2x. Then we were able to put everything in. And this problem, we were able to use the chart because we had x squared. Remember, you can use the chart when you have x to the n. And so we found all the derivatives and then all the integrals. And then we cross multiplied. And then the first one was positive, second one's negative, and the third one's positive. And we put all of that in. And we got this answer, which I forgot to square. I've been trying to square the answers to the problems with just a red line. I square the formulas with the thicker line, so you know that's a formula. Okay. And then here I said, oh, well, let's just evaluate that integral from 0 to pi. And so we took and we used this, the fundamental theorem of calculus says evaluated at pi and then subtract off. It evaluated at 0. And then we got pi over 8. All right, so this is another cat chasing its tail. And the only way you know it's a cat chasing its tail is if you go through the problem, okay? So this one's going to require us to use the chain rule, okay? So obviously this is one like the other ones where may not be sure what to use for you, but I can definitely say that dx has to be this part and it can't include the other part, so this thing must be u. Okay, so I let u be cosine of the natural logarithm of x, and dv, which is easy, is just dx. So the hard part here is finding du. What is du? You have to use the chain rule. What is du?
Is it you substitution 1 over x times sine the natural logarithms.
Okay, that sounds good to me. We got to take the derivative of the outside function, which is negative sine natural log of x, times the derivative of the inside function, which is 1 over x dx. And then v is just x. Good. Thank you, Celine. Okay, let's plug it in. U, natural log of x, times v, which is x, minus the integral of v, which is x, du is negative sine of natural log of x times 1 over x dx. So I get this integral is equal to the cosine of the natural log of x times x, minus minus makes plus, the integral. Notice that these x's divide out. So I just get the integral of the sine of the natural log of x dx. So, cat chasing its tail. Why? Because I started with a problem with cosine looking like this, and now I ended up with a problem with the sine. So now I have a new problem to do. So the integral of the sine of the natural log of x dx, I'm going to let u equal the sine of the natural log of x and dv equal dx. So now what is du?
Would it be 1 over x times cosine of the natural log of x?
Dx, that's excellent. Okay, we get the derivative of the outside function is cosine. And we have to take the derivative of the inside function, gives me 1 over x. Okay, so now the integral of the sine of the natural log of x dx is going to equal uv, which is x the sine of the natural log of x, minus the integral of v, which is x, and du is 1 over x, the cosine of the natural log of x dx. So therefore the integral of the sine of the natural log of x dx is equal to x times the sine of the natural log of x minus the integral of the cosine of the natural log of x plus, I'm sorry, dx. Aha. Okay, so it looks to me like the cat found its tail. So now I get the integral of the cosine going to equal x cosine of the natural log of x plus x sine of the natural log of x minus this same integral. It pops back up when the cat chases its tail. Well, I'm trying to find my mouse. It's so weird when I lose the mouse. Don't ask me where the X went. Okay, so now I have 2 of them on one side. There's the mouse. Equals x the cosine of the natural log of x plus x the sine of the natural log of x. And so now I'm done. This is equal to x the cosine of the natural log of x plus x the sine of the natural log of x divided by 2. Plus c. And we are done. Okay. So we finished that section. All right, so guys, I'm gonna tell you right now,